Okay, in this video, we're going to focus on covalent compounds, naming of binary molecular compounds, meaning compounds that are made up of two different non-metals. Remember, all the ionic compounds we were talking about in previous videos, they were a metal and a non-metal, or a metal and a polyatomic ion. And these were ionic compounds that had charges, and that the net overall charge was zero when the cation cancel out the anion charge-wise. But with covalent compounds, there are no charges, and the way to name them and the way to figure them out is that you name the first element and you write down a prefix before the name of the first element, and you name the full first element, you write down a prefix. By a prefix, I mean you tell me how many of that first element you have. And then you name the second element, but with an "ide" at the end, IDE. Remember, like with the binary ionic compounds, you name it with an "ide", also putting a prefix telling me how many they are. What do I mean by prefix? Well, these are the prefixes. 1 stands for mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, and 9 is nona. You don't normally use the mono for the first element, but you can use it for the second element. So for example, CO is carbon monoxide. CO2 is carbon dioxide. Notice we did not use the term mono for the first one, but we used it for the second one. Okay, let's take a look at this one. Here's an oxygen and here's 2 fluorines. So this would be oxygen difluoride. Okay, and this one over here is 4 sulfurs, so tetrasulfur. So you say the full name of the first element, tetrasulfur, and then tetranitride. Okay? And what if I give you a name and ask you for the formula? This is dinitrogen tetrafluoride. So dinitrogen tetrafluoride. Tetra meaning 4. Okay. What about this one over here? Carbon disulfide. What would that be? Carbon, just 1 carbon, and 2 sulfurs. You get the idea? Now, with the hydrogens, they don't normally put any prefixes with hydrogens unless we have that scenario with the hydrogen phosphate polyatomic ions where you use monohydrogen phosphate or dihydrogen phosphate. But for example, something like this, you don't say dihydrogen sulfide, you just say hydrogen sulfide. Okay? And I think covalent compounds are super easy to do. One thing that a lot of students mess up on quizzes is, let's say I give them this and I tell them name it. A lot of students will look at this and say, oh, that's the nitrite polyatomic ion, and Dr. Wabi just forgot to put the charge. No, I did not forget to put the charge. This is a molecular compound. This is not a polyatomic ion. So what would it be called? Nitrogen dioxide. They do the same thing with this one sometimes. This is sulfur trioxide. This is not the sulfite polyatomic ion. Okay? Now, if I put a 2 minus here, then yeah, that is sulfite. Okay? But without the charge, it's sulfur trioxide. Okay, so that's naming of binary covalent compounds. Before I jump into the acids, I just wanted to make sure that I mentioned something about mercury. Mercury exists as 2 types of mercury. Mercury 2 plus and mercury plus 1. But here's the thing, mercury plus 1 is not a monoatomic ion. It's a diatomic ion, meaning it has to exist with another mercury. So mercury always hooks up with another mercury. So when the 2 of them are together, they become 2 mercuries, just like the diatomic molecules, but the total charge is going to be plus 1 and plus 1. That is a total of plus 2. Okay? Good. Do you guys remember the diatomic molecules I don't know which video I'll mention this in, but may as well put them in here. There are 7 typical diatomic molecules. You've got the halogens, so fluorine always exists as 2 fluorines together. Fluorine, chlorine, bromine, iodine, always diatomic. And also the gases, hydrogen gas, oxygen gas, and nitrogen gas. These are the 7 diatomic molecules. They always exist as 2 atoms of that element hooked up together. And then there are polyatomic molecules like phosphorus many times will exist as P4. Sulfur is also a polyatomic molecule that sometimes exists as S8. Okay? But I digress. Let's go back to acids. All right, there are 2 types of acids. There are binary acids and there are ternary acids. Binary meaning 2 elements. An acid, by definition, is a substance that has, there are lots of definitions for acids, but for our class, we're going to focus on the Bronsted-Lowry definition that says that an acid is a substance that will donate a proton. And what is a proton? It's a hydrogen ion. So every single acid we're going to see has a hydrogen in it, hydrogen ion in it. So the binary acids, binary meaning a hydrogen and one other thing, one other nonmetal, are all of those halogens, like if you put a hydrogen with a fluorine, or a hydrogen with a chlorine, or a hydrogen with a bromine, or a hydrogen with an iodine. These are all examples of binary acids. So you could call this hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide, but when they're in water, they behave as acids. They donate their hydrogen ion. So I'm just going to put an AQ here. And now we're going to have to name them differently. AQ meaning dissolved in water. AQ. Okay, so what are we going to call them now? This is hydrofluoric acid. And this is hydrochloric acid. And this one would be hydrobromic acid. And this one is hydroiodic acid. Okay? So binary acids, you have to use the term hydro. Are there other binary acids? Yes. Let's say you put this with a sulfur. Well, sulfur is going to need 2 hydrogens. When you think of the structure of sulfur, the Lewis dot structure of sulfur, it has 2 electrons that aren't paired up. So you have to pair them up with 2 hydrogens. Anyway, sulfur would be hydrosulfuric acid, not sulfuric, hydrosulfuric. Why hydro? Because it's binary. Anytime you have a hydrogen with just one other non-metal, it's called a binary acid, and you have to use the word hydro. Another one you should know is if I put 3 hydrogens with a phosphorus, this would be hydrophosphoric acid. Okay? So those are the binary acids. What are the ternary acids? The ternary acids have oxoanions in them. What do I mean by an oxoanion? I mean a polyatomic ion that has an oxygen in it. So a nitrate, a sulfate, a sulfite, a chlorate, a chloride, those ones. So let's see what the typical ternary acids look like and what are the oxoions. And this is something that you should know. If you've got a polyatomic ion that ends with 8, the acid is going to have an ic acid at the end. If you have a polyatomic ion that ends with ite, you're going to have an us acid. Okay, what is that? Well, let's say I've got this guy. Recognize that this is nitrate, and this one over here is nitrite. So if I put HNO3, and this would be HNO2, this one is nitric acid, and this one is nitrous acid. Let's try another one. Let's say I have this over here. And let's say I have this guy. So this is the chlorate polyatomic ion, and this is the chlorite polyatomic ion. So which one would be the ick and which one would be the us? The 8 becomes the ick. So this is chloric acid. Chloric acid. And then this one would be chlorous acid. Did you get the idea here? Okay, so what if I put a few up on the board, and these are typical things you see on quizzes. Let's say I've got, especially like the nomenclature quiz, let's say I have this. Okay, so these are 3 different acids. They're 3 ternary acids. They've got oxo anions in them. You see that this is sulfite. Yep. This one over here is perbromate, right? And this is phosphate. Okay, since this ends with an ite, what will the acid end in? Us. So this over here is sulfurous acid. Sulfurous acid. This is perbromate. So what would the acid end in? Ick. So this is perbromic acid. These rules, once you get the hang of the rules, it's really, really easy. I'm always amazed at how many people mess this up so badly because they just never paid attention to the rules. Once you got the rules, piece of cake. Okay, and then finally, let's do this one. This is phosphate. 8 means that it's going to be an ick acid. So this would be phosphoric. Phosphoric acid. Notice I did not use the word hydro. I did not use the prefix hydro. When do you use the prefix hydro? Only with binary acids, not with ternary acids. Okay? So, the last couple of things we're going to do, and I'll probably just put them in the next video. I want to talk to you guys about hydrates. I know that it's not on the what you need to know list, but let me just throw that in. We'll do hydrates, and then we'll talk about balancing of chemical equations and some rules and tips on how to balance chemical equations, writing equations and balancing them. Okay? All right. See you in the next video.